In this, I will discuss method of surface finish measurement. There are two methods for the measurement of surface finish. The first one is the comparative or qualitative method, and second one is direct measurement or quantitative method. The comparative or qualitative method is used for qualitative measurement of the surface finish. In this, surface texture is assessed by observation of the surface. The surface to be tested is compared with known values of roughness specimen and finished by similar machining processes. The various methods which are used for this type of comparison are touch inspection, visual inspection, microscopic inspection, scratch inspection, micro interferometer, surface photographs, reflected light intensity, well as surface dynamometers. Now first of all, touch inspection. It is used when the surface roughness is very high and the fingertip is moved on the surface at a speed of 2 square meter per milliliter second, and the irregularity up to 0.0125 millimeter can be detected in this method. In visual inspection, the surface is inspected by naked eye and the instrument is limited to rough surface. In microscopic inspection, a finished surface is placed under the microscope and then it is compared with the surface under inspection. The light beam is also used to check the finished surface by projecting the light about 60 degrees to the work. In scratch inspection, the materials like lead, plastic rubbed on surface are inspected by this method. The impression of these scratches on the surface produced then visualized. In microinterferometer, optical flat is placed on the surface to be inspected and illuminated by a monochromatic source of light. Surface photograph method. In this method, magnified photographs of the surface are taken with different types of illumination. The defects like irregularities appear as dark spots and flat portion of the surface appear as bright. The method of reflected light intensity. A beam of light is projected on the surface to inspect it, and the light intensity variation on the surface is measured by a photocell and the measured value is calibrated. Well as surface dynamometer. In this method, a pendulum is used in which the testing shoes are clamped to a bearing surface and a predetermined spring pressure can be applied, and then the pendulum is lifted to its initial starting position. After discussing the indirect measurement methods, now we will discuss direct measurement or quantitative methods. In these methods, numerical values of surface finish are obtained. The first in this series is Stylus Pro Instrument. The working of the Stylus Pro Instrument is like it as follows. It consists of skid, stylus, amplifying device and recording device. The skid is slowly moved over the surface by hand or by some motor drive. Then the skid follows the irregularities of the surface, and therefore stylus moved along the skid, moving in the up and down direction. When the stylus moves vertically up and down, the stylus movements are magnified, amplified and recorded to get a trace using mechanical methods or optical methods. Then this trace is analyzed by an automatic device. The advantage of this method is that any desired roughness parameter can be recorded, and disadvantage, fragile metal cannot be measured. Its cost, high initial cost, and for this method skilled operators are required to carry out the measurement process. Now Tomlinson surface meter, it uses mechanical cum optical means for magnification. The working of the instrument is shown in the figure. It has a diamond stylus. On the surface finish recorder is held by spring pressure against the surface of a lap cylinder. Then this lap cylinder is supported one side by probe, another side by ruler. The stylus is also attached to the body of the instrument by a relief spring, and its height is adjustable to enable the diamond to be positioned, and the light spring steel arm is attached to the lap cylinder. The spring arm has a diamond skyber at the end, and a smoked glass is rest on the arm. Now it's working. When measuring surface finish, the body of the instrument moves across the surface by a screw rotation. The vertical movement of the probe caused by the surface irregularities makes the horizontal lap cylinder to roll. This rolling of lap cylinder causes the movement of the arm. So this movement induces the diamond skyber on smoked glass. Finally, the movement of the skyber together with horizontal movement produces a trace on the smoked glass plate. Then this trace is magnified by an optical projector, therefore giving the measurement of the surface to be measured. Now third, in this quantitative measurement of surface finish, a profilometer is there. It is an indicating and recording instrument to measure roughness in microns. Its precision is very high. The main parts of the instruments are tracer and amplifier as shown in figure. The part of the tracer consists of a stylus which is mounted in the pickup, and it consists of induction coil located in the magnet. When the stylus is moved on the surface to be tested, it will be displaced up and down due to irregularities in the surface. This movement induces the induction coil to move in the direction of permanent magnet and produces a voltage. Then this voltage is amplified and recorded to measuring the surface finish. The last in this series of direct measurement is Taylor-Hobson-Tellier. This instrument is working by carrier modulating principle. It is an accurate method comparing with the other methods. The main part of these instruments are diamond stylus, whose radius is 0.002 meter, and skid. The irregularities of the surface are traced by the stylus moving in the up and down direction. The movement of the stylus is converted into changes in electric current as shown in figure. On two legs of the E-shaped stamping, there are coils for carrying an AC current, and this coil forms an oscillator. As the armature is pouted about the central leg, the movement of the stylus causes the air gap to vary, and thus the amplitude is modulated. This modulated is again demodulated for the vertical displacement of the stylus. So this demodulated output actuates or induces the